Okay. So in the first couple chapters, well, this is what we've done so far. So let's see. This is what you did before you ever came here. You did things like this. You did two.
Gosh darn it.
Okay. You did things like this. It said 3 plus, maybe it said X, but probably earlier than that, it had this like box, and it was a colored in box like this.
And it was gray.
And it said, yeah, it was gray, I don't know, okay. Equals 5. You had something like this. And then, so you just thought in your mind, what would I add to 3 to make 5? And you thought about it for a minute, or some of you might have had to take a little longer, but then you came up and you said, well, it must be 2, all right? So you didn't really solve, you didn't really use any algebra or anything like that. You just, in your mind, you sort of thought, well, what would fit in there to make 2?
Technically, isn't algebra the same way?
What's that?
Instead of a box, it'd be X.
Yeah, but I mean, that's what I'm saying. It's really the same thing, but you're not using any techniques. You're really just saying, what would X be, or what would the spot be? Okay? And then in the first couple chapters, you did something like this, where they gave you ones where it was much harder. So they might have said, like, 7x plus 1 equals 10, right? Well, let me do it a different way. You had something like that. And then, so you looked at that and you probably, maybe if you took a little bit of time, you could run through some numbers in your head and finally fill something in for X and come up with it like you did on the forts. But this is much harder. So what you did was you got these problems where they gave you this stuff. They gave you this domain, and then they said, you know, X is either 1 or 2 or 3, right? And so then you would try 1, and then you would say, well, 7 times 1 is 7, and 7 plus 1 is 8. Well, that's not true, so this can't be it. And then you put in a 2, and you said 7 times 2 is 14, and 14 plus 1 is 15. Oh, so this works. And if you put the 3 in, it would have been 21 plus 1 is 22, so that wouldn't have worked. So then they gave you the set, okay? So from now on, they're going to give you these hard ones, but they're not going to give you the set. So for the rest of the year, yeah?
Wait, is this 3-1 or 3-2?
3-1.
Oh. Wait, didn't we already go over 3-1?
Well, I had you write some things after the test in your notebook. I just had you write the properties, but we didn't really go over it, right? Okay. Okay. So now, from now on, we have to figure out, well, how do we find these without, if we don't have options, if they don't give us an option, if they don't give us a set or a domain, and it's too hard for us to figure out, how are we going to do that? So you see these big equations, which is, you know, 7x plus 1 equals 15, and, you know, like I said, if you sat there for 10 or 15 minutes and you started running through numbers in your head, you might get one. But as they get bigger and bigger and more difficult each time, that's going to be hard to do in your head. So when you see these things, it looks kind of like an ogre, a big scary ogre. Has everyone seen Shrek the movie? Has anybody not seen Shrek the movie? Has no idea who this is?
Ogres are
I don't know.
onions.
We're going to get there.
I like that.
All right, but everyone knows who this is, right? Okay.
I like cakes.
All right. All right.
No, they're like a parfait.
Everybody likes parfaits.
All right. So, all right. Look at me. Back to math. So these equations can be like big scary ogres if you don't know how to solve them. Okay. So I'll ask you a question, and you tell me. You fill in the blank. Okay. You ready? Shrek is in
Ogre.
ogre. Ogres are like
Problems.
Onions.
onions. You saw the movie, right? Onions, right? Onions have
Layers.
layers. Good. So what I'm going to do in this chapter is we're going to use some properties to peel back some of the layers on these equations to make them easier to solve, and that's the idea. So that you can learn some different things to solve these equations without having to do them in your head without a list.
Kind of want to watch the movie.
All right, so you wrote some of these. If you weren't here on Friday, then you didn't write them down. But all we did Friday after the test is we just wrote these in our notebook. So you can write those down if you haven't already. And they're the addition property of equality and the subtraction property of equality. And you're probably noticing, you think, man, just as I maybe start to get a handle. And by the way, I looked at the tests, and the class falls very easily into two categories. Those who memorized all the properties and know them, and those who didn't and don't know them. And if you don't, I give you a word of caution. They're just going to keep more and more. Every section, you notice, every section, every 2 sections, we add 1 or add 2, and they just keep building up. And so if you don't stay on top of those, you're going to really have a hard time. So if you need to review, you can review the book. One of the great things you can do is make little flashcards. That's what I do for myself, or did when I was your age. And I was learning these things. I would put like the addition property of equality on one side, and on the other side I would just write this, like A plus C plus B equals B plus C. You know, that kind of thing. So that way, when you see these things, you can kind of just flash yourself the flashcard thing, and you can, yeah, that came out wrong. You can, you know, use the flashcards to memorize those. You can go back and watch the videos. And you don't have to watch the whole 10 or 15 minutes. You can go on and watch the 2 or 3 minutes that we talk about a particular one if you're really not sure what it is. So, but we're going to keep adding these on, and they're going to become more and more important that you really get them. So, and then you're going to move into eventually doing algebraic proofs, and next year you'll be doing geometric proofs, and then you're going to have to use all these properties to justify and prove things, so they're not going to go away. So you can do that. That way in 2 years you don't tell whoever's teaching you math in 2 years, well, you brought that back again. Well, it's never going away. These aren't going to go away. As long as you do math, you're going to need these things, okay? So the addition property of equality says this. If A and B are equal, so let's start out and come up with some equal things. Give me a number, Hojin. Any number.
21.
Oh, is your name Hojin? Pick a number, any number.
Nice.
3,065.
All right, 3,065. All right, now Tim.
21.
You're going to get, no, listen, it said A and B are equal, so you got to give me something that's equal to that. But don't give me 3,065. Give me something else that would be equal to that.
Oh, A plus B?
No, something that's equal to 3,065. Anything?
3,064.
Right.
3,064 plus 1.
Okay. 3,064 plus 1. This is, guys, this is the substitution principle, right? The substitution property. You can substitute one thing for the other. These things are equal. Everyone agrees with me that those are equal. All the addition property of equality says is this. Because these are equal, as long as I add the same thing to this side of the equation, the equal sign, and add that to this side of the equation, as long as it's the same, it doesn't matter. I can add anything I want, as long as it's the same. All right, Eric, pick a number. Any number? 2. So 3,000, I'm telling you that 3,065 plus 2 is equal to 3,064 plus 1 plus 2. And if you did some quick math, you would say that this is 3,067, and this is 3,065 plus 2, which is also 3,067. And those things are equal. And so that's the idea of, that's all that the addition property of equality says, is as long as you add the same thing to both sides, it's still a true statement. It's still equal. Okay? And in the same way, the subtraction property of equality is sort of the same thing. Pick a number, Shay. 7. And you got to pick something that's equal to 7. 4 plus 3. Okay. And so the subtraction property of equality says as long as I subtract the same thing from both sides of the equation, then I'll still get a true statement. I'll still get something that is equal. So Nathan, pick a negative number. Negative 2. So 7 minus negative 2 is equal to 4 plus 3 plus, I'm sorry. I'm sorry. 7 minus negative 2 equals 4 plus 3 minus negative 2. Okay? So if I subtract the same thing from both sides of the equation, I should still get an equality, something that's true. And so we can review this real quick. So we're going to turn this into an addition problem, right, Eric? So how am I going to rewrite this one? 7, when we subtract, we add the opposite. What's the opposite of negative 2? So when we what?
I don't understand. That's the thing I never understood. Why does it go from being a negative 2 to a positive 2 if you're just swapping the sign? But that, why would you guys...
Well, you're saying, that's what you're saying, it's swapping the sign. What I'm really doing is adding the opposite. When you subtract something, you add the opposite. Because if you have just a simple thing like 6 minus 1, you're really adding the opposite of 1, which is negative 1.
Oh, but if you have 6 minus -1, you get 6 plus +1, but like,
Right.
but,
Because you're adding the opposite.
but is that just through algebra or is that through everyday life? Would you use it? Because
Well, it's everyday life, but you probably can't visualize that because if I tell you that you have $6 and then I'm going to take away -$1, well, what is -$1? -1 means you owe me money. That's a debt that you owe. So if you have $6 and I take away a debt that you owe me of $1,
that'd be 6 minus
You-
-1.
it would be 6 minus -1. You have $6 and you're taking away a debt you owe me of $1.
Okay.
Now you're worth $7 because now not only do you have your 6, you don't owe me the $1 that you owed me before. It's very difficult to think of it that way, so that's why we think of it as adding the opposite. That's a lot easier because when I tell you that subtracting a minusing or subtracting a negative number, you don't really know what that means. Unless you have to take some really time to think about that. As you get older and you have debts and bills, then it'll be a little easier to think of those. But.
$7.
So this is 7 plus 2. Okay, Alex, how am I going to rewrite this side?
4 plus 3 plus 2.
Plus 2. Good. And of course 9 equals 7 plus 2, which is also 9. Okay? So you can see that that's true. So that's the addition and the subtraction property of equality. That's all it says. So you can, anytime when you have an equality, you can add the same thing to both sides. And so this is what confuses some of you when they start throwing the letters in, right? And I know that. So all that's saying is whatever A and B are, as long as you add the same thing, see, it's plus C. As long as I'm adding the same thing to both sides, it's still true. And you can add, because it's commutative, you can put whatever you're adding to it in front of it as well. It doesn't matter. Okay? The same numbers added to equal numbers, the sums are equal. And it's the exact same thing with subtraction. If you subtract the same things, the minus C, whatever the C is, you can pick from both sides, then it will still be equal. Okay.
Magic.
Transforming an equation into an equivalent equation. Okay? So, we're going to transform these equations. We're going to change. Transform just means to change. Okay? So we're going to change these equations by three different methods. So the first one will work as transformation by substitution. We substitute an equivalent expression for any expression in a given equation. Okay, so don't yell when you see these. Okay.
It's an onion.
Yeah, so you got Shrek there, you got some onions. Okay, so the first thing we can do is, let's rewrite this. Here's an equation for us, and they want us to solve it. Okay, so the first thing we'll do is let's transform it using some substitution. So all I want to do right now is simplify this. Use what we learned in chapters 1 and 2 to simplify this, to rewrite this sentence to make it a little bit easier. So Weston, how would I rewrite this? We're not solving anything. How am I going to rewrite that?
I know. So, -6 plus
Well, start with what you have there, right? B, and we're going to change our subtraction to a,
plus -6.
well, yeah, -6. There you go. And then, once you have that, then how can you simplify that? Now is where you're going to use that transformation by substitution. If I'm adding -6 and 14, what can I substitute for that?
8.
Positive 8. Good. So I can say B plus 8 equals 100. Does everyone see what I did? All I did is substitute -6 plus 14. That's the reason we learned that in chapter 2. We learned how to add positive and negative numbers so that we can transform things through substitution. So that just becomes an 8. That's all that property says, is that you can substitute equivalent things equivalent expressions in a given equation. So as long as they're the same, you can substitute them in. So next we have transformation by addition and by subtraction. So this just says that you can add the same real number to each side of a given equation. It uses the property that we just learned, the addition property of equality, and the subtraction property of equality says that as long as you do the same thing to both sides, then you still have a true statement. Okay, so what number could I add to both sides of this equation, Felix? What number could I add to both sides of that equation?
2.
2. What else, Tim?
4 minus 2.
Okay, what else? Dan, what could I add to both sides of the equation?
Three plus.
3 plus 5? Sure. You guys are making it a trick question. The answer is anything. Anything you say, as long as it's a number, is correct. Because I can add anything to both sides of the equation. Not everything will help me, but I can add anything. Pick a number, Desiree.
8,100.
Well, let's pick a smaller number for the board so that I don't have to write a million things. Just pick a smaller number. Any number, doesn't matter.
910.
910. All right. So if I say this, b plus 8 plus 910 equals 100 plus 910. Is that a true statement? Are those things equal, Eric?
I have no.
The answer is yes, because as long as I add the same thing to both sides, that's a true statement. What I would get was, I would just substitute 8 plus 910, get b plus 918 equals 1,010. It didn't get, that looks a lot worse than this. That looks like a bigger ogre than this. So that wouldn't really help me solve this. But this is still a true statement. So one of the things one of the concepts you really have to grasp is that you can add anything or subtract anything from both sides as long as you do the same thing to both sides. All right. So now we come to the question is, well, what will help us then? So if I can add or subtract anything I want, what will help us? So we said these equations are like onions, right? So we got to this. b plus 8 equals 100. Now remember this property here. What was this property that said this? A plus negative a equals 0.
That's the.
What property? Anybody?
No, it's not identity. I can't remember which one.
Property of opposites.
Oh.
If you
Oh, yeah.
if you add things that are opposite, you get 0. Anything plus its opposite gives you 0, right? Ah. So, do you have a question?
It says onion had 5 layers.
Well, this one's only got 1 layer. All right, so this is what we're going to do. So you're going to look at your variable, which we know our variable here is b. Because b is what we don't know what it is. That's what we're trying to find. Because we know what 8 is and we know what 100 is, but you don't know what b is. So in order to solve it, you're going to ask yourself, what operation is closest to the variable? Closest, the heart of the onion. Well, there's only one here. By the way, just to review, operations, there's only 4 of them that you know. Addition, subtraction, multiplication, and division. Okay?
There will be more in the future.
What operation, Shay, is next to our variable? It's going to be one of these. These are our operations. Adding, addition, subtraction, multiplication, or division. Addition. So I like to write it. So when I make my onion, I write it. And it'll help me. I do like that. I make a little onion and I put a little plus sign in there. Okay? And so I know that in order to peel back the onion, if I want to peel that onion 1 layer at a time, I have to get rid of that addition. I have to, Dan, are you watching me? All right. We're peeling back the addition, and we do that by doing its opposite. What's the opposite of addition? So I'm going to subtract. So I'm going to subtract the same thing. The most important thing is that I subtract the same thing from both sides. Okay? So what number would I want to subtract from this side that would give me a 0, Eric? So I have an 8. What would I have to subtract to give me a 0? 8 minus what is 0? 8. Good. So that's why I'll subtract an 8 from both sides. Okay? Because 8 plus negative 8 is 0. So all I'm left with here is what? What's left? Eric?
0.
Well, I've got something there. B. B's not 0. And then, Eric, what's 100 minus 8? 92. Okay? So that's the simplest kind of equation you can have. So we know that B is 92. And then what I like to do is I like to just make a little stem here on my onion. You can do it this way if you like. And then I take my 92 and I put it back in for the B. I just write it there and substitute it in and rewrite my equation. And I say, is that a true statement? Just to check my work. Eric, what's 92 plus 8? 100. And 100 does equal 100. So I know that my answer is right. If you put your variable, what you solve it for, back into your equation and solve it, if it comes out to a true statement, you know you did it correctly. If it came out and said something like 99 equals 100, that means I made a mistake somewhere. I'd have to recheck that, figure out what I did.
Check the third.
Did I?
Oh, it's overloading.
You filled it.
Oh,
All
that's
right, I just
overloading.
want to make sure I'm on the right page. Okay. So now we're going to do some together. All right. Did we have questions? Or you just raising? Okay. Felix. X minus 7 equals 13. What's my operation closest to the variable? Which operation is closest to my variable? What did I say the 4 operations were?
Subtraction.
Right. Addition, subtraction, multiplication, division. It's subtraction. So I'm just going to write that up there. And I know that some of these are simpler and you're thinking, well, I don't want to write all that, but when you get to bigger ones and we get to multi-step ones, you're going to find that those are going to be very helpful. So if you do it like this, you'll help yourself in the long run, trust me. Okay, so Felix, if I want to get rid of my subtraction and my onion, what am I going to do?
Add and make this
I'm going to add 7 to both sides, is that what you're saying?
yeah.
Because the opposite of subtracting 7 is adding 7. If I have a minus 7 and a plus 7, that gives me 0, so all I'll have left is an x. And that's is what, Felix? 20. And then I do this, and then if I put 20 minus 7 equals 13, I can check that and see that 13 does equal 13. Okay? All right, Katie. Z plus 8 equals 31. What's the operation closest to my variable?
You subtract, right?
Right. It's addition. So I subtract 8. Very good. What's left?
What?
What's left after I subtract 8 here? I'm sorry?
0.
0 plus...
Z.
Oh, you had
Gosh
You
darn it.
can escape on that.
Nathan.
All right. Z. And what's left here? Z equals what?
0.
31 minus 8.
23.
23. Tim. Negative 52 plus m. Oh, I'm sorry. Let me real quick just. And if I put that in there, 23 minus 8 equals, or I'm sorry, 23 plus 8 equals 31. 31 does equal 31. And that's important. In these smaller ones, you may not need to check that, but you'll find that if you check your work like that, when you have a quiz or a test, if you do that and you check the work, you'll know whether you have the right answer before you ever get it back. You don't have to wonder, did I get that right or not? You can check it yourself. Okay. Who was I at? Tim. Negative 52 plus m equals 84. What is the operation closest to my variable?
Well, what you're going to do is for negative 52.
Well, first tell me what operation is closest to my variable.
Addition. Not
Good. Yes, it's addition. It's right here. Okay.
So
Alright.
the thing is, so like if you look at the other ones, it's can I look at the other ones?
You sure can.
I can't remember. Okay, so what you're gonna do is you're gonna have positive 52,
You're going to what?
positive 52.
Well,
because it's a negative 52.
it is. But what's the opposite of addition?
Subtraction.
Okay, so let's do a subtraction. Because when you have addition, to get rid of addition, you need a subtraction. So what would I subtract?
52.
What number do I want to get rid of?
52. Negative 52.
Negative 50. So I want to subtract negative 52. I'm going to run out of space there. Okay. What is negative 52 minus negative 52?
It's positive 52 plus positive 52. No, it's negative 52 plus 52. Negative 52
You're
plus
right.
52.
Yeah. Negative 52 plus 52, which is?
0.
Which leaves?
M.
Okay. 84 minus negative 52 is what?
Is positive 52.
It's adding, right?
Yes.
Minus a negative is
So
adding.
you'll get
Adding to the
100
opposite.
136.
136. That is correct.
Yay.
And for some of you who want to see that, who couldn't do that in their head, okay? Good. job. Nathan, you're up.
Say this is
Oh, let's see here. We have negative 3 plus 1 plus 9 equals 9. I saved the harder ones for you. Okay. So the first thing I want to do is I want to transform this equation by substitution. So what things there do I already know that I can sort of substitute for?
-3.
And
1.
1. Okay. So everyone see that? Negative 3 plus 1, you can substitute for that. What is it? It's negative 2. So negative 2 plus n equals 9. And so now once you do that, now you have the same problem that they had before. So what's the operation closest to my variable?
Subtraction.
Which operation is closest? This is my variable. What operation is closest? Addition. How do I get rid of addition?
You.
Do the opposite. Good. What am I going to subtract from both sides?
-2.
Good. What is negative 2 minus negative 2?
0.
Good, which leaves me. And what is 9 minus negative 2? 11. Because it's really just 9 plus 2. When we subtract, we add the opposite. So n equals 11. And if I put that back in, I'd see negative 3 plus 1 plus negative 11 equals 9. Negative 3 plus 1, negative 2 plus negative 11 equals...
Don't you get negative, negative
Oh, I
9
did.
there?
Yeah, I put 11 in, didn't I? No, 11's my variable.
You put in
Negative
-1.
3 plus 1 plus negative 11. Oh, I see. This was a... No, that's a negative.
Thank you.
Did I-
Thank you.
plus. It is 11.
Why didn't 11 be positive?
Where's my 11? Oh, it's a... I see what you're saying. I put a... Yes. I put a negative 11. It's a positive 11. Which equals 9. So 9 equals 9. Yes. Very good. Okay. Who hasn't went yet? Linda.
Danny.
You haven't had a chance to have any fun? Let's see. 11 equals 7 minus 1 minus q. So very similar to this last problem, you can substitute something there. So there's some things that you can change. What do you see there that you might be able to change? This one, everyone look it up. Because this one's going to confuse a lot of you. And the reason is because you have this negative sign right here. What is that? What number is in front of that negative sign?
1.
A 1. That's actually negative 1. They don't write the negative 1 because if there's just a minus sign, the 1 is understood. So the problem that a lot of you will do is you'll think this is 7 minus 1 minus q. But really, what is this? This is negative 1 multiplied by the quantity 1 minus q. What was the property we have when we're multiplying something by a quantity?
Distributive property.
Distributive. And this is what will make, guys, this is what will trip up some of you, is that you won't use that distributive property. So then I know that, what's negative 1 times 1? Who's that? Linda. What's negative 1 times 1? You were right the first time. Negative what?
1.
Negative 1. Good. What's negative 1 times negative q? We just multiply the numbers, so what's 1 times q?
1
Which is just q. And if I multiply two negatives, what do I get?
positive.
Good. Plus q. Good. So this is where you got to start. And a lot of you will make this mistake. You'll keep it minus 1 minus q, and you'll forget to change that to plus when it's on the outside of that quantity. That's super important. And I know that you'll probably make that mistake a bunch of times before it clicks and you start to remember that every time. Okay, so Linda, once I'm to this point, now I'm very similar to this problem. And I put an equal sign there, not a minus. Okay, so, and I'll just put so that doesn't look like a 90, I'll put a little q thing up there. Okay, so what is 7 minus 1?
6.
Okay, And so now we have a simple equation. So what is the operation next to my variable? Which is the operation next to my variable? Addition. And how do I get rid of addition? Subtract. What do I subtract from each side?
6, maybe 11.
Subtract 6. And that leaves me over here. What's 6 minus 6?
0.
So what am I left with?
Q.
Q. What's 11 minus 6? I'm sorry?
5.
5. And if I put that back into my original equation, I have 11 equals 7 minus 1 minus 5. What is 1 minus 5, Linda?
6.
If I have 1, I subtract 5.
Oh. 6.
If I start at 1, and whenever I subtract two numbers, one's a negative and one's a positive, I take the larger number and subtract the smaller, which gives me,
Oh, 1? I thought you said
5.
11.
I'm sorry, no, 5 minus 1,
4.
and I use the sign of the larger number, so it's negative 4. And then if I'm subtracting a negative number, what do I do? What is 7 minus negative 4?
Positive something?
When I subtract, what do I do? What is subtraction? Adding the opposite. What's the opposite of 4? Negative 4.
4.
And of course 11 equals 11. So we know that that checks as well. Okay? So remember, this is the part that's really going to be tricky, because I know that minus is going to absolutely get some of you guys. All right. Now we do this with absolute value. So the absolute value ones will be a little bit tricky as well. All right. So let's first solve for our absolute value. Find out what our absolute value is, and then see if we can get some answers. Okay. What is, Desiree, what's the operation closest to my variable? An addition. Good. So what am I going to do to get rid of that addition?
Subtract.
What am I going to subtract from both sides?
You're going to subtract 10.
Good.
Which will leave you z equals.
Well, not z. What's it going to leave me?
It's going to leave you
What do those things mean?
an absolute value.
Absolute value of z
Absolute value.
equals what?
18.
18. What does that absolute value mean? What values can I put in for z that'll give me 18?
3 times.
No, let's not make it too complicated. If z is 3, I'm sorry, if z is 3, what's the absolute value of 3?
Negative 3.
What's the absolute value of 3?
3.
3. What's the absolute value of negative 3? 3. What's the absolute value of 5?
5.
What's the absolute value of negative 5? So if the absolute value of z gives us 18, what two numbers can z be?
1 and 10 and 8.
It's just one number. What's the number?
18.
18, and what else? Negative 18. Good, Shay. Because no matter which one of those you put in, it's still going to give you 18. So this one has two answers, okay? Because the absolute value of negative 18 is 18, and the absolute value of 18 is 18. All right. We'll pick it up tomorrow and start the homework. I'll give it to you. Write it down. I forgot where I'm
Write it down and I'll write it down. Wait.
Write it down in your agendas.
Danny! Stop it.
You can do all the homeworks up through the word problems. This last part with the word problems you can save till the night before. We'll do those two practices first thing tomorrow. I forgot we're on the chapel schedule. So do this top part, this 98, 798, and the word problems you can leave off till the next day.